Hey, everybody who's out there streaming. Thanks for joining. We'll give it a few more minutes to let some stragglers roll in, but excited to hear all these presentations. Thanks for coming. Cool. I think we're ready to start. So, hello, everybody. Greetings, everyone out there on the interwebs. Welcome to those in the Zoom as well as those who are streaming. So, the Slingshot participants watching, fans of Filecoin, and even the random people whose YouTube algorithms suggested this stream. So, welcome all. We have a really exciting set of presentations today from projects participating in Space Race 2, Slingshot. So these teams will discuss their projects and cover things like what their project is and does, the data that's being stored, the inspiration for their project, and even diving into their technical architecture as well. Just a quick recap about what Slingshot is. It's a community competition for storage clients in the Filecoin network. The goal of the competition is to reward the storage of real, valuable, and usable data onto the Filecoin space race network, so the test network. It's a continuation of Filecoin's previous competition, Space Race 1, which was more focused on the mining side of Filecoin, so onboarding storage to the Filecoin network. And at this point, we have nearly 500 petabytes of storage in aggregate. So a huge milestone approaching that. And now in this phase, we're excited to see participants start to take advantage of the storage via Slingshot as we transition to mainnet launch next week. Slingshot, the competition, is split into two phases. So right now we're in the middle of phase 1. It started September 23rd, and it's currently scheduled to end next Wednesday, October 14th. And then give me one sec. Let me get my materials up. Cool. So here is the agenda for the day. So what we'll do is give a quick recap of phase 1 so far, and then we'll introduce you to the 6 teams presenting today. And then each team will give their presentation. And then towards the end, we'll give some quick closing words as we transition to the last week of phase 1 and start wrapping up this phase. So this timeline shows where we are in the competition right now. It's a 3-week competition spread out across 4 calendar weeks. And the last 3 weeks, 2 weeks, rather, the last 2 weeks have been action-packed. We've had a ton of projects entering, 90 plus teams on the leaderboard, 13 events that have taken place in these 14 days. And these events, we've heard from developers who have built the protocol itself and tooling around Filecoin. In master classes, we've gotten demonstrations from other client developers around how they built their apps and learned about that journey, and office hours as well. And as we transition to the last week, we'll be switching focus more to getting you prepared for the submission process. And we'll give some more details on this later, but expect updates in the coming few days about how to submit your project, the showcase, and the reward structure as well. Wanted to give a quick shout out to you all in the community. Thank you so much for taking this journey with us. Filecoin itself, we're in its testnet, it's in its beta, and it's a complicated machine, and we're still learning a ton of stuff. So having your participation has been really helpful. It's helped us understand all sorts of intricacies around the network, and we've just gotten tons of valuable feedback in terms of improving tooling. We've learned a bunch about what the developer journey of a Filecoin client like you will look like. And we're also extremely excited to have real data stored on the network and start to get the ball rolling on our goal to store humanity's most important information. Just a quick recap of where we are in terms of rewards in phase one. So we've unlocked, or you all rather have unlocked the 20,000 Filecoin reward pool from storing around 150 terabytes. Am I saying that correctly? And that's data as of a few hours ago. So I'm sure we're a little bit past that now. To put that in perspective, this would have required over 100 million 1986 floppy disks. So just a ton of storage of information that just a few decades ago we couldn't imagine storing all of. So huge congrats to everybody. And we're 2 out of 3 weeks in, and we've gotten our feet set under us in this competition, and we're really starting to see the amount of data stored accelerate. I think in the last 36 hours or so, seen 40 to 50 terabytes stored. So we see our ambitious goals up front, and we're excited to see you all reach them and unlock even bigger rewards. And as we transition to this final week of phase one, just wanted to give a quick couple of reminders for the rest of the competition. So do remember that there's a verification process that's going to take place just to make sure that you're storing real data. And this isn't intended to be an intimidating process at all, just to make sure that participants are fair to their other fellow participants. And we just want to make sure everyone gets the rewards that they deserve. All the data that is stored has to be tied to your use case, so either a data set or user data associated with your application. And just make sure also that anyone can retrieve your data via its CID, and that's going to be part of our verification process, but need to make sure that anyone in the network can do that. Make sure that you're storing data with the right licenses. And then as far as redundancy goes, it's totally okay for the purposes of your application or UI to have up to 10 copies of individual pieces of data. But without a legitimate reason more than that, we'll consider gaming the competition. And then just a quick heads up, we've had some questions about deals that are disappearing and things like that. Just want to make the general statement that you should make sure to store your data with healthy miners, because if a miner terminates a sector, it is irrecoverable and it won't show up on the leaderboard. Okay, with all that boring stuff aside, I want to transition over to why you're really here, which is to learn more about your fellow projects and about the cool stuff people are building on top of the Filecoin network. So today we have FinFile, Free Music Archive Browser, Orion Deep Learning Cloud, Slingshot Scavenger Hunt, and IPFS Scholar presenting. The Starry Sky Yunnan team, I didn't see them come in yet, so they're last anyway, so hopefully they'll join by the end. But we'll at least have five presentations, so a lot to look forward to. So we'll start off by having John come up, John McLaughlin. He's the CEO of McCurse Capital, and he's going to share FinFile, which is financial and digital asset data store, where users can find fundamental, technical, and use data on a given asset that can be stored for investment research and analysis purposes. So please, John, take it away.
Okay. David, can I stop your share?
Yes. I'm getting off.
Okay, everybody. So FinFile allows the user to generate a stock chart, cryptocurrency chart, as well as a CSV data chart, Excel file of data. In our newer iterations, we're working on adding news feeds, access to videos on a given asset. Also, we're trying to create a digital store, a financial asset and digital asset store so that you can get historical data on any asset going back for as long as there is information available about it. Who's going to use this information? You could have stock investors could use it, cryptocurrency investors. We all know that the traditional financial services markets are mature and they probably wouldn't use something like this. But in the cryptocurrency world, all of these things are brand new. There's a lot of new projects out there, and the turnover of information is very, very rapid. So that's what we're trying to get FinFile to be, so that people can store information. We'll also store information on it, and then they can retrieve it for investment analysis. If you had a hedge fund that wanted to invest in a digital asset, if individual investors wanted to, they could do that. They could do that too with the app. We've pushed our data using PowerGate's products, Textile PowerGate products. The PowerGate is great. We've been able to store a bunch of really, really valuable data with it. We've also used Textile's Hub, which this screenshot that you see down here is you can send over your CID and then you could break it apart and you can actually look at the pieces that are inside of it. So Hub is pretty cool. We've also used our Python. FinFile is a Python Flask app, so it works really great with PowerGate and Pygate, which is a Python version of PowerGate. So you can use that to stage and push your data into FFS. Actually, what you see on the screen here is I pushed a whole bunch of data about Bitcoin Cash. I don't know if there are any fans of that out here, but I found a lot of valuable data about that today, and that's what you see up on the screen there. So if you went, you looked at that CID and you opened it up, that's what you would find. Another use case for it is generating charts with the app. You could generate a historical chart from it, overlay another asset on top of it. In this example, comparing the price action in Ethereum and Bitcoin, and you could kind of tell during certain periods of time which asset was a better performer than the other. There's still a little bit of kinks that we have to get out of it, but we're trying to increase that functionality too. Okay, so here's the flow of files. Here's how it would work. Via API, we're getting a feed from New York Stock Exchange, major crypto exchanges such as Binance, Bitfinex, NASDAQ stock market. Users can get that information themselves through our app, store it in the hot layer of of IPFS and then retrieve it quickly for just like a quick in and out, just for like a minute by minute analysis. But the real major purpose of it is to push it to to cold storage. Let's say you were a hedge fund manager or an investment manager, and you you wanted to build a whole lot of data so that you could analyze it to build, say, a portfolio. Let's say you were building a bot, a trading bot. You could take our data and you could create your algorithm using all of our data. So there were two groups that are actually pushing to it. It's the individual users. There are institutions could do it, and also we would be the third, where we're enhancing the quality of data that's in the data store. So we're always constantly pushing and updating news items, videos, updated charts, that kind of thing. So what do we have to do moving forward to automate this process? We're going to hook up, we need to hook up a gRPC client. We're almost there. We had the Textile team was real helpful, and so was the Pygate team in helping us develop the gRPC client. So it would automate it. So when people are requesting this information from the app, it's getting pushed directly into IPFS. You're getting your CID, and then you can later push it into, staging it in IPFS and then pushing it into Filecoin. We're trying to get access to more APIs. We're actually thinking of getting the chain link oracles and hooking those up to the app, so that we're going to have many sources of valuable data, much more than we have right now. We also want to work on the UI and the aesthetics and the functionality, adding a whole bunch more to it. So let's take a look at, get back there. Let's take a look at the app itself. Okay, so let's say that you wanted to get a chart on the company Snap. Snapchat, which is a social media favorite these days. Maybe not a favorite today. Oh wait, there we go. There's a chart. Okay, so the app generates a chart. We could download the image of the chart. We're going to drop that into our demo directory. We can also get a CSV spreadsheet of it, save it there. And then what we're doing now is manually first we would need to create the PowerGate FFS instance. Okay, and then that's going to give us our token here. We're going to need that if we're going to stage. So let's say, what do we want to stage? Okay, how about that Snap? That Snap file. Then we need our token. Okay, so now we're staged to hot storage in IPFS. Let's take it one step further. And now we want to send it to Filecoin. So we pick up our CID. Need our token again. We push it through. Okay, and there we go. So now that chart that the app generated, it's now on Filecoin. You could go on to IPFS, and actually, if you wanted to inspect the CID from the hot layer, you could type in the CID here, and you'd be able to see what the file was. So so that's it. We got a lot of work to do, but it should be a really nice app once we add a bunch more functionality to it and we automate that process of pushing to Filecoin. Okay. Thank you.
Awesome. Thanks so much, John. That's great.
You got it.
It looks like there's one question in the chat around the size of the data for an individual ticker.
Oh, okay.
About 5 kilobytes.
This is great. Okay. This is great. Look from associated quarterly reports, etc., stored alongside the financials. Yeah.
There's a question.
Oh, Pooja
right
up there. Okay, this is awesome. What's the size of the data for one ticker like this? It looks like 5 kilobytes. Yeah, it is 5 kilobytes. That is the size of it. But obviously, the things like a quarterly report, you know, then you're talking several megabytes. But these things are not really big. It's the associated like videos, you know, like with the founders. Like I like there was a whole bunch of videos with the Vitalik Buterin, and we uploaded those, and they were kind of helpful. And also like how-to videos, like how to install MetaMask, things like that. Those were obviously much bigger because they were videos.
Awesome.
Okay.
Thanks so much, John.
Got it. Thank you.
I appreciate the walkthrough as well.
Sure.
So next we have Charles, or no, not Charles, Fayan coming up, sharing free music archive browser, his project, which uses Filecoin to store media files. So Faye, if you don't mind.
All right, hey guys, I'm gonna start my presentation. So my project is fairly simple. It's one of the curated data set free music archive. I'm located in Surrey, Canada, which is part of the Vancouver area, and I'm a software developer. I also like to assemble PCs and stuff. I did Ethereum mining in 2017 and started Filecoin mining in June. I only have one rig right now. This is my rig. It's just a simple 3700X as a CPU and 128 RAM. So naturally, once I finished the Space Race 1, I went on to the Space Race 2. I look at the data set that is available. I will recommend it from the list. I picked this one, the Music Archive browser. On the GitHub of that data set, there are 4 sets of data, which is different sizes. I chose the large one, the third one, as a starting point. Once I unzip it, it has 156 folders. And each folder is pretty much the same size, about 1 gigabit. I naturally use the PowerGit to store the whole folder as one CID, which is working pretty well. I think it's it's a big advantage of the PowerGit. And initially I thought I'm gonna zip it and unzip to a temp folder to serve to user, but then I realized it has the whole folder feature, which is great. This is how I intake the data. I use the JavaScript API to do a simple for loop of the folder and just stage them one by one. And I also stored the job ID and CID into a MySQL database. So by using the PowerGit, it's much simplify the staging process because it will take care the replication automatically, and it also can cap the fee that it will take from the man. It will cap the fee that we'll spend when we're making the deal to the miners. And also during the development and my testing, I found out right now the default PowerGit config is not great for retrieval because it has the hot storage disabled. Also, I encountered a pretty low success rate because even though the PowerGit uses the recommended list from the Slingshot competition miners, but still lots of miners either don't take deal or they have failed sectors, so later the deal failed. Also, we encountered the high base fees causing making deals extremely expensive. It will quickly drain all the Filecoins that are available. But PowerGit team has been great in responding my questions and making fixes as I discover. So it's been great working with them. My application is a web application. It's built with a Meteor, full stack Meteor JavaScript network framework. It incorporates with the official JavaScript PowerGit client. When user requests a music genre from the web page, it will call PowerGit to get the whole folder into a temporary location. Then user will immediately see the available soundtracks in the web page. Because it's using the Meteor JavaScript framework, it's very reactive. It's like it utilizes WebSocket to do dynamic pushing into the web page. So user don't need to refresh the web page to see the result. There is some future work right now. Initially, I also designed to allow visitor to record and upload their own audios so that we can pack and upload to the Filecoin network. There is also to extract metadata from the Free Music Archive dataset. Right now, there's no metadata available yet. Their music archive has API for the metadata, but it was down during my development, so I couldn't retrieve them. Also, it would be great for PowerGit and Lotus to allow retrieving a single file from a whole folder so that I don't need to prepare a temp folder. I can just use the PowerGit /IPFS directly. So to see it, this is the data set that was, this is the data set, the Free Music Archive. When I go to here, it provides the zip file here. I chose this one and intake myself using my own script. Then this is the application. Here's some information about my PowerGate instance. It's self-hosted. And on the data set, there's a list of all the folders that I stored, and their CID is available for anyone to query. So when you want to access one of the data set here, you can just click the retrieve. It will wait a while. Then it will be available here. You can see the data set is now 001, which is what I just did. The audio are all here. That is playable right on the browser. Yeah, that is all. That is my app. Thank you.
Thanks so much, Fei. That's so cool. And it's great to see that there are some wins and some improvement areas, but the community thing is working where you're talking directly with the PowerGate developers and talking to us. So
yeah, exactly. Yeah. It's people always on the Slack 24/7. It's always something new.
Cool. There's one question for you in the chat asking about the difference between the large and the full FMA zip, and is the difference just more files?
I think the musics are the same music, but on the large one is partial of the music, so the total size is reduced, easier to access. I plan to upload the full zip in the end.
Awesome, thanks. Cool, so appreciate it, Fei. We can move over and have the next presenter go. It's Charles Cao. So Charles is the CEO of Nebula AI, and he's going to present his project Orion Deep Learning Cloud. And it's a container-based GPU cloud computing platform that has an S3 compatible general storage service store to hold unstructured data, so photos, videos, etc. And the project is currently under the Canada Next Generation Network support. So really excited to hear more about this project. Charles, please go ahead.
Yep. So, hi everyone. So just let me share my screen. Yeah. So today we bring everyone the Ariel Deep Learning cloud platform. So basically, like this is a GPU cloud platform designed to using GPU resource as well as storage to help people doing the machine learning. So, and this is, people are confusing about what is the relationship between Ariel, Mbfs, and Nebula AI. So basically, like Nebula AI is our company. We're based in Montreal doing the cloud computing. And Mbfs is the Nebula 5 system, which is, we're using this name to participate in the Space Race 1 as a miner. Now in the Space Race 2, we're working as a developer. So the platform itself using for GPU computing, we call it Ariel. So basically, it's one company. I have the two project line. Yeah. So this is a high level platform design. So with our company, we are designing a platform which you can either choose the decentralized application to do the cloud computing based on GPU and the other infrastructure like Filecoin CPU resources. And we enable people to doing the machine learning with decentralized apps. So basically you can use a smart contract to using token to pay and buy services. And we would like to integrate with the Filecoin blockchain so we can using the blockchain storage resources. So this is on the business side. And this is the storage with contract design. I would like to building a platform And the core part is the task pool can assign different tasks from the GPUs and the clients. They can submit different contracts through the contract networks. So you can use smart contract to doing the down payment, ask miners to taking the task, GPU tasks for you, and distribute it to the different GPU miners. When you need a storage, the GPU miners will asking support from Filecoin network to get a storage as a cold storage. So you don't need to save the data on your local storage and upload it every time. You can retrieve from Filecoin network and doing the GPU computing on real time. And you don't even need your GPU resource because you can ask a miner who has GPU to do the job for you as well. So this is our system design. The project was initiated about 3 years ago. We are waiting for the day when IPFS and the Filecoin project become mature so we can integrate it. Now is the day, so we are so excited to working with the Filecoin ecosystem to building this app and deliver it to the market. So now we're talking about why what we are doing in this space with 2 about the Ariel. So first, we support we're using Pygate. And so you can using Pygate to communicate with upload the files, retrieve files, and doing the machine learning as well. So we support a container-based database. Basically, like an Ariel platform, you be able to initiate a container, for example, MySQL container. So you don't need to install container on your MySQL database on your local. You can directly init MySQL DB. And when you have machine learning services and you want to using GPU, you just need to press one button and you can open the GPU acceleration for your algorithm to do machine learning. So we managed to deploy the service on multi-data center. So, and this is supported by Canada Next Generation Networks. They help us finish testing within 3 data centers in Canada, Ottawa, Calgary, and Montreal. So we'll be able to transfer different GPU containers across data centers. So which means that if you don't have enough GPU in one data center, yeah, be able to using the GPU data center in Calgary or Vancouver. And we embedded a PowerGate engine. So you don't need to install PowerGate by yourself. You just go to platform and upload your files, and you can using PowerGate upload to IPFS and Filecoin networks. So we provide a GUI-based file uploader. So when you upload the file through the GUI, you'll be able to have your own user ID, so you can fetch the individual for yourself. For big data more than 1 gigabyte, we provide the choice to chunk it to small data files, for example, 300 megabytes each, and then you can retrieve it and upload it much easier to avoid the data streaming interruption during the uploading process. Yeah, it's a little bit too much while reading the text. So let's see a demo video. So this is the video we have. We recorded this morning. And yeah, can I make it bigger? Yeah, so this is when you upload a file from your interface. You click upload, you can see the speed bar to show the transmission. After you finish uploader, you will see all the history uploader you have, and it has a CID here, the file size, and you can click a button when you're trying to retrieve it from the GUI. Yeah, this is just a simple file uploader. Yeah, let's go to the next slide. And this is the GPU part, sorry, the deep learning part. So when you go to deep learning, you can choose go to the task list, and you can copy your CID. After that, you can turn on a notebook instance directly from the interface, and it will pop up the Jupyter notebook. So if you notice here, there's a button called GPU on and off. If you click the on, it will automatically attach a GPU to your system. Otherwise, you can just like this, you copy the CID, copy your name, you change the name here, and you click run. You can start retrieving the data from the network. And this time we're retrieving a data set called Nemo. data set, which is we are download lots of limit data set from remote worker to local storage. Yeah, then you can unzip the files after retrieve. And you can see that the files is created here. So you can go through here to see all the data sets inside the browser. Yeah. So those are a whole bunch of different name images. Then you can do in the image recognition, writing your own deep learning algorithm inside the Jupyter Notebook. And when you think it's too much, you need to accelerate, you just click the button here, and you are done. So this is the Ariel platform, but we have more cool features, which is not showing here, the smart contract part and the Ariel storage part. And we also support storage to directly upload to the Amazon and Google platform. So if you're previously working on Amazon, AWS, and Google, you don't need to worry about the big synchronized work. You just need to go to our, we have a component called Signals, which is the commercial name is General Storage Component, GS2. You just click the synchronize button, it will download all the data for you, and you can pass it to the Filecoin network directly. Yeah. And yeah, now talk about some development tools we're using during the development stage competition. So this is a terminal we running at the backend. Here is a PowerGate part. It have compliance, complicated uploading process here. This is the rooters node. So while I'm development, I have 3 windows open at the same time, so I can see how the process going when people upload the files. The logs here. I can tap client to watch the DLs going, and then this one is for fast test, so it can just manually using CRI to trigger a command if something goes wrong. And this is a small batch uploader engine, which allowed you, if you want to upload a big data set, but you don't want to go through the browser, because browser only allow you upload 1 file at a time or zip file. You can use this program. We plan to open source it very soon. So with this development tools, it allowed you to initialize your token, your port, and you can define a source file directory and the out source file directory. Basically, like it will scan all the source file directory, all the files there, and chunk all the files to the size you want. For example, I set as 300 here. Then it will iterate all the files, all the small pieces, upload to the system, and they will create the CID and the pieces ID in the backend with the small database. And yeah, and this is the 3 folders you will use for doing that. You have a source folder. You can sorry, add all your files you want to upload it here. Then you will have, after the chunk process running, batch process run, they will generate also different pieces, chunked files has the pieces ID here, and you can, each of them will have a MD5 hash to make sure that when you retrieve it, it matches the original data. Yeah, this is our team. It's we are located in Montreal, and this is where they installed the different machines, the data center in Montreal. So quite interesting. Yeah, thanks everyone. And this is pretty much what we are doing now.
Awesome. Thanks so much, Charles. This was really cool to see. And honestly, like storing a bunch of data and deep learning go hand in hand. So it's cool to see a tight integration there, especially tackling it in a decentralized way. And I think the mission of the Filecoin network and what you all are working on pretty aligned. So we really appreciate seeing it. Thanks for sharing.
Yeah, thank you.
Great. So next up, we have Jim Pick. So Jim, he's a freelance developer in Vancouver, and he's going to share his project Slingshot Scavenger Hunt. And the project demonstrates in-browser Filecoin retrieval of a subset of Wikipedia data. And the goal is to kind of gamify it and support some gameplay elements where players can go from place to place and upload additional materials that can be archived to Filecoin. So Jim, please take it away.
Hi. Okay, I guess I'm on. Okay, I'll share my screen. And okay, so Slingshot Scavenger Hunt. I'm calling it gamified knowledge graph building. So it's under construction. I can't really show too much of the actual game yet. I'm planning to work on it this weekend to try to build some gameplay elements into it. So, but what I'm building the game around is a small subset of Wikipedia. And it was originally built as a project called Datpedia, and it ran in Beaker browser using the DAT protocol. And it was a sort of a nice 3 GB set of small version of English, simple English Wikipedia. So it's not like full English Wikipedia. It's like English, simpler sentences for international audience or people who are learning English. And so I'll show you what I have. What I'm going to do in the game when I build it is I'm going to give each player their own Filecoin wallet, and they will directly use Filecoin as part of the gameplay. And the players will travel from place to place, and there'll be Wikipedia pages associated with them. And I will ask them to complete certain tasks, and if they can complete them, and these tasks are going to involve finding additional bits of information that they can attach to the Wikipedia pages, and storing that data on Filecoin, and also seeing can other players retrieve the things that they've stored. So there's going to be a very strong geographic element to this. So I'm going to switch away and just show you some screen share stuff, and but mostly what I've done at this point is just storing the data into Filecoin. So I want to show you the tools I've built to do that. So like right now, I'm only my data set's only 3 GB in size, and it'll be bigger because people will contribute more to it. But I've just been storing the base set. And if you go to the site right now, it just says this. It's going to have more, hopefully after this weekend. And here's the original Datpedia site project that I started with. That had like the 3 GB version of Datpedia. What I did was I took that 3 GB zip file and I broke it into 700 small chunks, so all about 5 MB in size, because I wanted to be able to download these chunks directly from Filecoin into the web browser. And I initially started and I stored all those. But just in the last week, I found out that, like, because of the gas issues and things, we don't want to have the participants in the contest storing really small files onto Filecoin, because the miners can't really handle that. So I've now switched over to storing much larger chunks of Wikipedia. So this is the modified version of Datpedia. I'm just calling it Slingshot Scavenger Hunt Wikipedia. So if I search for, like, say, New York, and this is using a hot layer, so it loads really instantly. I also want to demonstrate loading it directly off of Filecoin. So Filecoin retrievals take maybe 3 or 4 minutes in my testing. So I would like to actually sort of show that. But then I don't think people want to wait that long. They're going to want to use a hot layer. So I'm providing a hot layer here. I have some ideas for that. So there's another one. And we got images. Now, what could people do with the gameplay? They could, like, go and they could say, this is the simple English Wikipedia, and it's from several years ago. Like, go and fetch the latest version of Wikipedia in English, or maybe Chinese, like in China. So, like, and store that and somehow link it into the UI for this. And then people will register and they'll get a name and things. So. And that's the concept. It'll make more sense when I get more of it built. So one of the things I'm doing that might be different is I'm not using PowerGate. I'm working directly with the Lotus layer directly, and I run my own nodes. And previously I was working at Protocol Labs, and I worked on a thing called Lotus.js client, which was a JavaScript library to talk directly to Lotus nodes. And this was a graphics UI I used to test the original storing of deals and retrieving of deals. And I've built in a miner discovery. So this scans every single miner that's on the Filecoin network, and I add metadata, and I can geolocate where they all are. And what I've been doing every morning is I've been like taking all these lists of miners, and I can basically take a little camera image, and there it is. So I can take that picture, and then I can just store on all. I can basically click propose 10,000. It'll store this image on every miner in the Filecoin network. It's a very small file, and what happens is when you do that, I have here are like basically those 1,500 miners, and I can categorize each of them and figure out like which ones are responding to deals, which ones like a lot of them, because it's a small file, they'll say, I won't accept the small file, I'll accept these larger files. So this has just been in the last week or so. So I've added some extra steps to this where I do a second pass of testing where I'm storing larger files to figure out which miners are accepting deals. And I'm publishing all this information on, let's see, and you might have seen me posting this in the Slack. So this is all my small files and my output. And so I know which ones to make deals with, and I've added extra annotations for the medium files. So this is all the, so I've tried storing files with everybody in this list of 256 megabyte files, and I have test results, but I haven't updated this yet. So I'm going to demonstrate how I'm storing the files very quickly. So right now I have Wikipedia, the 3 gigabyte one, split into 13 different chunks, and I've been making deals with all these different miners, trying to figure out which miners are responding. And you can see each of these chunks, like how many I made a mistake here. You're only supposed to store 10 of any file. I accidentally store 17 because I made a mistake. But I've got quite a few active deals out of these, but also a lot of errors because a lot of times the transfers don't go through. So I'm just going to, if I have time. So if I store batch, and I've done some scripting around so this is all shell scripts, and it'll just pick one of my miners off of my list here of the candidates, and just hit enter to start a deal. And I did some expect style scripting with Go around the Lotus client tool. So it'll automatically check the price and decide whether to accept it or not. And then hit enter, so it'll just automatically go and make that deal. And takes a few seconds and then moves on to the next one and hit enter again. And yeah, so with this technique, I can very rapidly make deals with every single miner on the network that's open to deals. And then I've been posting the output, the results from that. So you can, if you're looking for more miners accepting deals, I recommend going to this file. I should have this updated later today. And I'm also categorizing them by price, so you can sort of see how much I've made the deals for, and the active ones are the deals that actually sealed. So okay, that's all I have for now, and I'll hopefully have more gameplay after the weekend.
Thanks so much, Jim. Awesome. And a model community member as always. So appreciate the extra work you're doing there, and also excited to see what comes out of the game. And it sounds not only like a great demonstration of Filecoin, but educational as well, and then presumably fun. So yeah, excited.
Thanks.
Cool. So We just have one more presentation. The Starry Sky team can't make it. There's a little bit of a miscommunication there, unfortunately. But so our last presentation will be Yue Li with IPFS Scholar, and it's a decentralized platform for academic publishing. And she'll cover the different application scenarios and methods, the problems that Filecoin is helping to solve, and then future prospects of their project. So please, Yue, take it away. Hey, Yue, I can't seem to hear your audio. Are you speaking right now?
Yeah.
Okay, awesome. There you are.
Hello, everybody. My name is Chen Huimin. I'm from China. As one of the participants of our project, I'm very glad to show you our project, IPFS Scholar, a decentralized academic website. My presentation will be divided into 3 parts. First of all, I will give you a general introduction of our project. Then I will introduce the role of Filecoin. And the last part is about our future work and vision. IPF Scholar, similar to Google Scholar, is a website for storing and downloading academic papers. This academic platform is a decentralized platform, and all academic materials are distributed storage. There are 2 roles in the system, the author and the reader. The author can upload their files, and the reader can download the files what they need. Here is our homepage. The homepage is mainly composed of a search box and a certain subject classification. There are 2 ways to retrieve papers. 13 first class disciplines classified the academic papers of each subject. Here is our demo. Here is our important code. Through the Polyget API, the file are stored in IPFS and the Filecoin in turn. By the way, Polyget is a fantastic design. Here is a search box. You can search the files by keywords. Here is.
Real quick, we're still seeing the PowerPoint screen. Maybe you just shared that one window.
Sorry.
No, you're okay.
Can you see my homepage?
Yeah, we can.
About it, how it works. The author will upload the paper and store it in IPFS and the Filecoin network. The reader views the paper by category or by keywords. Readers who download papers must pay a certain amount of Filecoin to the contributors. The role of Filecoin provides the right confirmation for the paper, which is a high-value document. Filecoin provides a kind of self-storage, which can self-serialization better. Filecoin is a kind of storage with a lower cost than server, greatly reduce the operation cost of the platform. And P2P transmission enables users to send or obtain files with lower delay. About our future work, we hope to perfect the valid module to give users a better experience and optimize the search engine. We will try more ways to large and wider range of text search. And we want to gather initial users and increase the user activity. The last, we hope to go to mainnet. Our vision, we aim to create a platform for academic freedom. Here you can experience your thoughts freely. There are no publishing fees and heavy reviews here. Your academic achievements can be quickly known to peers. Here the data belongs to you, not to the platform. And the data income is in your account. That's all, thank you. That's
Awesome. Thanks so much, Wei. That was great. And honestly, like academic research is part of what makes us human. So it's really great to see teams working on storing that data and making it discoverable and making sure that people get the credit they deserve. There is one question in chat about how someone gets income off the platform.
you can, it's by a reward. It's no limit. Just you can, when you upload a file, you will provide your wallet, and the reader who downloads the file must pay in advance.
Got it.
And
yep. Sorry, go ahead. Oh, no, sorry, I cut you off. Please go ahead. Cool. All right. Well, really appreciate it. It's cool to see this project, and yes, would love to see this on mainnet when it's out next week. So thank you so much, and thanks to the whole IPFS Scholar team. So like I mentioned before, Starry Sky couldn't make it, but just wanted to give them a quick shout out. They're storing meteorological and astronomical data, astronomical, that's right, of Yunnan University. So things like charts, data analysis, and pictures, and storing this valuable data on the Filecoin network. So be sure to keep your eyes peeled out for them, especially as we transition over to the showcase phase of the competition. I know we're already over time, but just wanted to really quickly share a few closing thoughts as we head into the final week of the competition. So again, thanks so much to the teams who volunteered to present today at our Slingshot-and-Tell. We are truly amazed at the progress that y'all have made so far. A lot of really cool use cases, and also gives us a ton of hope and excitement for what's to come. The competition is currently scheduled to end next Wednesday, the 14th at 1800 UTC. So just keep that in mind. As we transition to the end of the competition, please just continue to review the rules on the Slingshot website, as well as keep your eyes peeled for more details on what we're going to need from you for your submission, and for getting you the rewards that you deserve. That's all coming soon. I think you should hear some stuff on that tomorrow. Yeah, so that's all we have. I realized somewhere in the middle of the conversation that are the presentations that I'd never introduced myself. I'm David, part of the Filecoin and IPFS teams at Protocol Labs, and you might see me floating around Slack, and call me out if we're not answering your questions. Love to engage with all of you, the community. Yeah, and excited to see the potential Filecoin getting realized. I think we can sign off here. Appreciate your time, everybody.